Hello, everyone. So this is a talk about the whys and hows of unit testing. So we're basically going to break down unit testing and testing in general, not just unit testing. We're going to talk about integration testing a tiny bit about end-to-end testing. We're going to talk about its value, why it's important to do it in our projects, why it's important to tell the client that we should do it in our projects and we shouldn't ignore it. And yeah, we're also going to dive a bit deeper into unit testing. We're going to talk a bit about Jest with some examples. The reason why I'm doing this presentation, and the reason why I think it's very important to do it, is because when I joined, I was so bad at it. Like, yeah, I could not write unit tests, so I really needed a guide that will basically tell me step by step how to write them. And that's what I tried to make. Okay, so what is software testing? Software testing is a process of evaluating and verifying that a software product or application does what it's supposed to do. So simply put, basically we have some code, it has a purpose, and then we're testing it to see if this purpose is fulfilled or not. And that's basically what it is. Why it's important. So many of the other projects are MVPs, and that means that we have a big focus on delivery and on features, but we should not omit testing. Testing should be a part of our MVPs always. It's important to pitch our clients about testing because it will basically make the product better and our lives as developers better. And will also allow us to deliver features faster and easier. Let's break this down a bit. So, first of all, the benefits of unit testing are it gives us early and accurate feedback, not only to us, but to every stakeholder of the project. It allows us to detect issues in the code and how they impact the features, basically, and our delivery. It gives frequent and actionable feedback at multiple stages of development. So this way we're able to detect problems early, and then we have a clear way of fixing them because our test tells us, okay, the problem is here. And then we should have a testing strategy because it allows us to detect and analyze potential risks. And having analyzed the risk, we can now communicate that to the client. So that will build trust between us and the client. What else does testing do? So it reduces the cost of defects. So this is something that we talk about a lot in Untitled. So as you have seen, we have stuff like, A, B, C, the stage of where we catch a defect. So so the earliest you catch a defect, the less cost it has on development, on the product, on delivery, on everything. And having a clear and good testing strategy helps us catch those defects earlier. And it also reduces the overall cost of resolving these defects. So if a defect gets to prod because we didn't have any testing strategy or no CI, that's a problem. And it will be costly, like in terms of time, in terms of points, in terms of everything. It also helps us speed up our release cycles. So if we have a clear test strategy implemented in our app and we want to add new features, we're able to do that faster because we know that our functions are well maintained, we know that they work, we know what they do, and then we can update them. And that allows us to also adapt our product to the market faster because our product is better and more easy to maintain. But the advantages don't stop there. We have improved software quality, improved efficiency and effectiveness of our code and our tests. We reduce downtime if a problem happens, and many, many more. So let's talk about the different types of testing. So I'm not going to talk about, there's many, but the three that I want to cover are unit testing, integration testing, and end-to-end testing, which are, I guess, here at the others, what we mostly focus on. So unit testing is basically the way we define each type of testing is by how much of the code it tests. So a unit test only tests one function, one component. And it also, because we're only testing one function, it means that we need to mock a lot of things. So in a unit test, we basically will test functionality of a specific component, and we will mock any outside data that we want to use. It will be fake data. Integration testing tests multiple components. So we will have an integration test that will test, how a function interacts with another function. And because we do that, we have to mock a bit less because we're using like actual real data. And then we have end-to-end testing. So end-to-end testing is basically overarching test suite that covers everything. So it will mostly test front-end, like UI components. So something like Cypress might test your user flow, test if your buttons work, if your API calls work. And your unit testing will basically, I'm going to finish the next slide. So yeah. So to go a bit deeper into how these tests interact with each other, I've made this I guess, pyramid. So first, as James pointed out to me, we have static code analysis. So that is like the first step. So it's all the red lines that you see, every like error that you see in your editor, that is that. When you actually write your code and you get past that, you can make a unit test. And a unit test just tests your functions, your code, as I said before. An integration test goes a bit further. So it might test some sort of API call, it might mock it might do something like that, or some database. And an end-to-end test will test everything. But the reason why it's in a pyramid is because all of the different test types depend on each other. So without static code analysis, we can't run a unit test because we'll have red errors everywhere code won't run. Without the unit test, we can't have integration tests because the integration test tests different components. We're testing with unit tests. So we can ensure with the unit test that our components are okay, and then we can basically test them together. And with our end-to-end and with integration tests, we can ensure that all components interacting with each other work well together, and therefore our end-to-end test will have a less chance of failing because the end-to-end test basically tests everything. But the problem with this is that the higher you go, I guess, in the pyramid, the more time, effort, and the more fragile your tests are. So a small test that is like very close to start the code will probably break your end-to-end test, and it takes a lot more time to maintain them. So having invested time in all of these pillars will allow you to make each of the, I guess, the test strategy above it be easier to do. I don't know if I explained it very well, but the more you have, the more I guess you have like a basis of testing, the higher you go up, it's easier to create these tests, easier to create end-to-end tests. And we have manual testing, which is overarching. So this is where we get a bit more technical. So if visitors are bored, sorry. So let's talk about Jest. So Jest is a framework that we're used to test. It allows us to, it's basically a JavaScript framework. It allows us to test JavaScript and TypeScript code, and can be easily integrated with React or React Native. And let's jump straight into an example. So these examples that I have basically in this presentation are really simple. Is what I wish I had as a new joiner, what I wish I saw. And they basically go through the fundamentals. So let's say we have a function that we want to test that adds two numbers. So yeah, add two numbers, number one, number two, and it outputs number one plus number two. What does the test of that function look like? So this is the test, but let's break it down and see how we build that test. So first, we need obviously to import the code that we're testing. We need to have the function to be able to test it. Then the way Jest works is it has some keywords called describe and it. Describe basically is the function that holds your whole test. So let's say that we have a component in our app and it has a hook. The describe will be most likely will be the equivalent to the hook. So your describe will be your test suite of that hook. And then your it will be your test cases. So test cases would be, let's say I'm testing one specific function, I'm testing different paths of the function if it has if it's breaking, if it's branching out to different functionalities, stuff like that. So first we have the describe, then we have the it. So the it is our test case, add two numbers. Then we actually run our code and we pass it into a variable. That's the simplest way to do it. And then this is the key part of Jest is the expect. So here, this is what determines if our test will pass or not pass. So what we do here is I don't know if this is very visible, so I'll go up. So yeah, you can see expect result to equal to. So I don't know why my formatting is weird. This code, the thing that I put them in to get the screens was really weird. So yeah, basically the expect result to equal to. If result is equal to 2, it will give us true. And if it's not, it will give us false. And that will cause the entire test to fail. Yes, so let's talk a bit more about expect, because expect is, I think, the basis of Jest. So expect basically takes in a mock function, which I'm going to talk about a bit later, or it takes a variable, and then it tries to basically compare it to something else. So if you give it, for example, a number, and you say expect to equal another number, it will basically assert if these numbers are equal. And it has many keywords you can play with. So the most important ones, I guess, I've highlighted them, some that I've used a lot. So to have been called with, so if you pass in a function and you check if it's been called with a specific variable, you can check if the function has been called at all. You can check if it's equal to something. You can check if it throws an error with to throw. You can also do not and all of these, so the opposite. Yeah, there's many different things that you can do. And there's like this doesn't even scratch the surface. In the documentation, you will find a lot more. So let's talk about another example. So is number positive? This is basically takes the number, check if it's positive, returns true, returns false. Yeah, sorry, they're very simple. What does the test for that look like? So the test basically checks, this is the same process before. So we check if it's positive, and if the result, I guess, will be a Boolean. If it's true, we return true. But there's something that we aren't testing here. And this is where I want to get into code coverage, test coverage. So what is test coverage? So test coverage is a metric of basically how much of your software code is covered by your tests. It helps you understand how well your tests are exercising your code, and it can help you identify areas of your code that are not being tested. And basically, the way Jest does that is it outputs a table that shows you how, like, the percentage of, I guess, for each file, the percentage of code that you're testing. So the different types of, I guess, coverage that you will see is branch coverage. So this is what I kind of talked about before. So if you have something like an if and it branches into a true and a false path, and you only cover the true part, it's 60% because you didn't cover the false part. Function coverage, how many functions you're testing. Line coverage, in the functions, how many lines you're testing. So let's talk about, so this is basically the output of Jest. This is what you will see when you run the coverage. And this is what I would say a bad coverage looks like. So you're not really testing anything. You're testing some parts, but like some functions do not have tests, do not have anything. They're all zero. Yeah. What does good coverage look like? This is from a field. So everything amazing, 100%, so good. But there's a problem here. There's sometimes, this is again from a discussion that I had with Jane that was really interesting. So even if you have 100% test coverage, that might hide some problems. Sometimes, when we write code, we write a lot of functions, we write a lot of business logic. We don't want to test everything. Some stuff, it's like, we don't really need to test. And having to test it makes our code very hard to maintain. So the problems hiding in 100% test coverage are that we can't really tell the quality of our tests through coverage. We can't distinguish between unit and integration tests. Sometimes also trying to achieve 100% coverage will force us to write bad tests. And also, one other thing on this is that it will make our tests harder to maintain if we're always trying to reach that metric of 100% and everything green and amazing. So let's look at another example. Is this good test coverage? Oh, sorry. Yeah. Is this good test coverage? This is an in-between situation. So it has a lot of greens. It has some parts that we're not testing. But I would say this is a good example of test coverage, but it depends on how the developers justify the parts that are not tested. So you can see that, for example, in customer.service.ts, we have like 70% statement coverage, I guess. And if I go ask the developer, why haven't you tested this? If they're able to answer me and give me a good pragmatic answer, that means that is an okay for this test, for this coverage, I guess, table. But if they can't give me an answer, it means that they don't know exactly what their test covers. So that is a problem. So this can be a good or a bad example, but it depends on if the developers know what they're testing and I guess how much of their code they're covering. So going back to our very simple example, obviously it has 50% branch coverage because it only covers the true of the if. And how we would fix it is like this. So we would add another test case, so another it, that will check if the number is negative, we would pass a negative, and then we would expect it to be equal to false. Okay, so this is like the very basics, simple stuff. So now let's talk about mocking. So basically in your unit tests, you might want to test, for example, some sort of API, you might want to test something more complex, or you might want to use data from something that is a bit more complex. But because it's a unit test, you shouldn't just call these functions because then it's not a unit test anymore. So this is where mocking comes in. So mocking is a way to simulate behavior of a certain module or function and basically replaces the functionality of that module with a fake one. So the way you would do this in Jest is with jest.fn. This is just a mock function that does nothing, and then you can assign properties to this function. So you can do something like mock return value, where you say, okay, this function will return whatever. Or mock implementation, where you say this function, you pass in another function, and it does something. Where do we use mocking? So this is important. So it's important to know when to use mocking and when to actually call the actual function and make an integration test. So I guess good examples to use mocking in are APIs or external services. When we want to use something like that, we usually want to mock it. We don't want our tests to make API calls. Error handling that is hard to trigger normally. Something like a database, we probably mock the data in like a unit test. If we have some sort of complex or hard to set up dependency, or something that is relevant to a project that we did before, was if the code interacts with hardware, so something like Bluetooth, you should probably mock the device and mock the data that it sends you back. So then it's like much easier to interact with it in your tests. Because if you're having, for example, a test that's running on GitHub, it won't be able to interact with your Bluetooth device, so it will fail. So that's where you mock it. Let's look at a simple example of an API call. So this is a get Pokemon function. So you all probably remember the Poke API that gives you all the Pokemon. So this is just a function that gets one Pokemon, given its name. And then it just returns this like small JSON name URL. How do we test this function? So we first need to mock the library that we're going to use to call it. So in this case, we're using node fetch. So we need to mock node fetch and scrap it. Like we don't want the API call to happen. We want to replace it with our own, basically return. Then we would need to create an instance of the data that we want to return. So here we're returning this Pokemon and its URL. And then, as you saw before, we're using this fetch function to actually get the data. So we need to mock this fetch function, because otherwise we won't be able to call it. So we basically create this fetch function and we say, okay, you're going to return the mock JSON that I created. And then it's the normal, I guess, flow of the test. So then we basically run our function, and because now we've mocked the library that this function calls, this function will not make an actual API call. It will call our function that we make, our mock function. And then we can assert the Pokemon to be equal to our mock Pokemon. And you can do other stuff. So I said before, if you have, let's say, error handling, something like your API might return an error if you pass in the wrong, I guess, parameters. You can handle that as well in a test case. Let's talk about spies. So spies are very similar to mocks, but they have some small key differences, I guess. A spy records, so what a spy does is it records information about a function call. It doesn't really care about what the function does, but it cares about how it's called. It does not modify the behavior of the function, but it allows you to see if any parameters were passed, how many times it was called, stuff like that. And you can do many stuff with spies, a lot of stuff with spies. So you can spy, for example, I don't know, class, you can spy, we don't really use a lot, but I wanted to put it in. So the way you would do it is, this is not very visible, sorry, but if you have, let's say, a function within an object, I don't know, and you want to spy on it, you would pass in the overarching, I guess, module, object, whatever it is. You would pass in the function, and then that creates a spy on the function. So then when you run your expect and you check, and you want to check how the function was called, you will actually check the spy, and the spy will actually know how the function was called and what it is doing. Not what it's doing, but how it's called. And you can do the same with something like a module. So if you have a function like this, it will function in exactly the same way. So you're importing the module, and then you're passing in the spy with the function, and then the spy just looks at what the function is doing and tries to understand how it's being called. And why is it important to use spies instead of, I guess a big question that I had when I was working with Just at the start is, why can't I put a function inside of expect? Because it will error out. And this is the way this problem is solved. We just use the spies and the mocks to basically check its functionality. We don't really want to call the functions themselves inside of the expect. So some other important keywords that are good to know. So it's the before each and the after each. So before each basically is a function that runs before all of your tests. So let's say you're mocking like a lot of stuff, but a different test case wants to change that. You can clear all of your mocks and restart them basically, and you can do that in the before each, so you don't have to put this in all of your function calls. And the after each does the same, but for after. So whatever you put inside of there will run after your tests. So that's it for the code part. I guess now come some good practices when writing unit tests. So, first of all, we need to talk about the design and writing of the test. So as I said, you need to arrange your data before you actually make your test. That means whatever mocking you need to do, I don't know if you're mocking some sort of device, if you're mocking some sort of API call, whatever it is, you need to do that first. Then you need to actually write your test, and that will basically allow you to verify that your mocks are correct. And then you need to assert that your function that you wrote, basically, if you call it in the test, returns your expected results. So that will happen in the expect, as I said before. In terms of quality and maintenance, in your tests, you want to test one thing at a time. So focus on one piece functionality. That will allow you to isolate bugs. So as I said before, when you're making unit tests, you want them to be very small, basically, they need to have a purpose. And then if a bug comes up at some point in your end-to-end test, some sort of error, you can track it down to your unit test. And you know what component, what module, whatever it is, caused that error. You want to use descriptive test names, that's obvious, because, for example, if you have like an it, you need to say it does some specific thing, because otherwise you won't know what your test does. If you have like a giant test file, you won't understand anything. You need to refactor tests along with your code. So, yeah, that's obvious. Like, if I'm writing some code, I can't just leave my test behind if I want to refactor it, because then my test will fail, and then I won't trust my tests. So I need to be refactoring, maintaining my tests as much as I'm maintaining my code. And another interesting thing that I found online, maybe you guys can challenge me on that, is that you need to have, I think, 1 to 3 times more lines of test code than actual code, which is really interesting. I didn't know that was a thing. And I don't know if I necessarily agree with it, but yeah, it just gives you like a good impression of like, you need to have a lot of tests, even if it's not that ratio, you need to have tests for most things. And you need to have tests that are small and fast, because if you have tests that have 1,000 expects in them, then they will run very slowly. That's an error we're facing in our project right now. So like, yeah, you should basically make them small and easy to run. So about execution, you need to have tests that run automatically. So you don't want, so something like a CI or like an overnight test running, I don't know, something like that, will allow you to check for defects all the time and allow you to basically use your tests as effectively as possible. Because why would you write your tests if you're not actually running them? And you want to use code coverage tools, as I explained, but you need to be aware of why you're not testing a specific part of the code base, and you should not just blindly follow the 100% test coverage everywhere. Yes, so that is basically the end. So some key takeaways from this is that testing is important. We should not ignore it. Even though we're making MVP products, we should basically always remember the value of testing and try to pitch it to our clients. Sometimes it's better to slow delivery down just a tiny bit just to maintain our code quality, because then we won't be able to add more features in the future. We might encounter bugs, we might encounter problems. When it comes to testing, I explained basically what jest is. So some key takeaways from that is we use the describe for our whole test, it for the test cases, and expect to assert if it's, if your test is passing or not. And yeah, basically on test quality, you should always try to maintain your test as much as possible. And yeah, I think you should test a lot. I like testing. I think it's important. But yeah.